Now recording. So, model view controller architecture. In the last class, we discussed how PHP is sort of built off this, there we go. PHP is built off of this concept of file level modularity. Rather than placing the abstraction mechanism in functions primarily, or even object-oriented programming primarily, the PHP classic registered trademark way of approaching the world is to imagine each PHP file as a separate operation that you call to perform some action. So PHP is sort of, in the old way of thinking, modularized at the level of files rather than being modularized at the level of functions. This approach has limitations, some fairly important limitations. It's basically just a complete pain in the arse to get anything working with it. You very quickly end up in a spaghetti code-like situation where you have all kinds of functions all over the place that are intercommunicating with each other, maybe, it's a mess. Model view controller architecture is a modern web architecture. This is the architecture that is implemented by a fairly high number of frameworks, not least of which is Laravel. You guys know Laravel? A little bit? Can anybody tell me the language of implementation of Laravel? It's PHP. So, if you're looking for, if you're like, oh, this is, this PHP course is kind of like, who does PHP these days? It's like, yes, true, very few people do vanilla PHP development, but Laravel does actually have some degree of user base. It is the framework that's based on PHP. You need to know how to program PHP to use the framework, roughly speaking. So, that's, it's not like PHP is a complete dead end, right? Like, there are things you can do with it. So, model view controller architecture. Everybody, I hope, remembers from Java the model view distinction, right? Anybody care to summarize?
View is the front end of the program that handles all the inputs and output and basically presenting stuff to the program user, and the model is the back end that has all the processing.
Yes. So the view is the front end, which has all of the user-facing code, right? The model is the all of the business logic, it's often termed. In our case, the view in a web application is generally HTML, CSS, and client-side JavaScript. These three elements compose our views. Our model is a great deal of the PHP code that we are learning how to do. But we add this third element of a controller. So, essentially, in your Java applications, there was no real need for a controller because your applications were not sufficiently complicated to require one. Most of them were just, let me expose some methods in some of the model classes as like options in a text-based interface, right? You weren't really, there was no middleware really there between you and the model. It was just here is my presentation of the model. Here, in web, we do need a middleware layer. It is useful to centralize incoming HTTP requests. If you do that, you have a portion of the controller, or you have a portion of the program which decides what parts of the model are appropriate given what I have received. What views are appropriate given what I have received and what the model gave me. And this is what model view controller architecture does. So, this is how it works. There we go. So, let's imagine that we have our erstwhile end user sending HTTP packets. Under MVC architecture, the thing that has the responsibility of communicating with the user is the controller module. Controller. The C in MVC. Having received a packet, the controller decides what parts of the model are necessary for this request. So, the model generally takes the form, in PHP, of a collection of functions or objects defining behaviors, some of which are called to process the packet. So it's essentially a library. The model is responsible for performing the business logic, making the decisions, right? If we are trying to perform an operation such as a login request, we're going to hear a lot about login requests in this course. It's a very good example. Validating if a username combination, which the user has given you, is in fact a valid username combination, that is the responsibility of the model. And from the perspective of the controller, all it needs to do is say, model, could you call login check please? Give me a Boolean. Is this correct or is this not correct? And the model will consult things and say, no, not at all. This is a very bad password combination. So the model is speaking, it's the thing that speaks to permanent data storage, right? It is the thing that talks to your database. It is the thing that talks to your file system. And it is also the thing that talks to a thing that you will not have heard of yet. The session database. These are different databases which are stored in different places. Don't worry, we'll get there. About the middle of the course we'll get here, right? But the model is what's responsible for talking to data storage, right? In order to determine if a login check passes, you need to consult however you're storing your database, storing your username and password combinations. Most likely that's going to be an SQL database. One of these guys. The model is what talks to it. Make sense? So far so good? So, the model then reports back to the controller about, did this operation succeed? What is the data that that's been requested here? all of this kind of stuff, right? The next step is for the controller to select a view based on the results from the model. Again, coming back to a password check, if the login attempt was successful, we should show a different website than if it was unsuccessful. Obviously, right? Most often, if a login attempt is unsuccessful, you give them the login page again. But if the login is successful, you show them something like a dashboard, right? So we can imagine that you have sort of clusters of front-end code, right, which constitute the views. We would have, the login page and the dashboard page, right? These might share components, right? But in general, you've got a bunch of files, some HTML, although really those will be .php because .php, JavaScript, and of course, everybody's favorite, CSS. The controller picks between these views and sends to the client whichever of those clusters of files. Well, you guys know how this works by now. You send the HTML file, and the HTML file loads the other necessary resources as secondary steps, right? So we are selecting the view according to what went on here. Once the view has been selected and populated with whatever data needs to be populated, we then send our response packet back to the user. They see their web page. Does this make sense? This is a process that we're going to follow all the way through from, basically in the second half of the course, we will be building towards the implementation of model view controller architecture. Make sense? Okay, any questions? All right. The architectural advantages of MVC architecture will become obvious as soon as you've actually seen it implemented. Once you've tried to implement one of these things, you'll see how much better it is. But it's really kind of difficult to describe as like abstract knowledge. You kind of have to get in there and get a feel for it. So we'll leave that for later on in the course. So there are a couple of other points here which may be of interest to you. I'm not going to be going through them in class, but there is a quick reference sheet for PHP. We can take a look at it briefly. Just kind of like regular quick reference. There's not a whole lot to say here, except maybe a couple of operations regarding arrays and strings. So count is your function for determining how long an array is. So in Python, this was len. In Java and JavaScript, this is some variant of the dot length, right? Here, it is count. You're counting them. This only works for arrays. If you want to determine the size of a string, you must use strlen, string length. String length, the string length function is a function from the C standard library. You'll find a lot of the ways that you work with strings here are sort of more or less transparent exposures of C standard library functions. This is perhaps one of the more direct exposures of it. Yep. There's a function here where you can get a PHP script to send email, only if the mail server is configured, which of course, for CS Unix, it is not. So, yeah. Any questions? Very good, very good. All right. There's also a set of practice problems. Here we go. Some of these you can't really do yet. In fact, pretty much all of these you can't really do yet because you need to, you need to be able to take input from the user, which is like literally the next thing we're going to do. So, you should, if you want some exercise, there's some practice problems there for you. Another excellent resource for practice problems for PHP and other languages is W3 Resource. If you take a look at, there it is, PHP. PHP tutorial for beginners. Ads. Blah. You can see it gives you some like teaching material as well, but somewhere in there are practice problems. Exercises, there we are. As with most things, you have to be, boy, the ads are getting really aggressive on W3 Resources these days. They must be losing money. If you require more practice problems, you can also pick some from here. At the moment, we would be like, we'd be in the neighborhood of PHP basic exercise practice solution. So, make sense? All good? All right. So, we've already talked about arrays to a fair extent. I'm going to skim through this to see what we haven't. I'd like to get to like the interesting part today. So, historically speaking, in PHP, the way that you created an empty array was using the array function. PHP has been updated so that you can now use square brace notation, like most other places. This is array management in a more Python style. These sorts of operations are performed in Java using curly braces, I believe. So, we have discussed associative arrays and how to get things out of them. You may declare them using double arrows. Yes. Good, good, good. Yes, yes, yes. You can iterate through numeric arrays. This is how you do it. with the for each loop. And that's how you do it for an associative array. For each C as key gets value. This is a form of pattern matching. So it is possible to access array elements from within a string if, though, you're using quote characters within a string, you will run into syntax errors because, of course, you shouldn't use quote characters inside of quotes. Especially not the same quote as is the delimiter for the string. The way that PHP provides to get around this problem is to enclose the array access in curly braces. You put the mustaches in there and it works. Make sense? This is somewhat similar to JavaScript format syntax, if anybody has worked with it. So far, so good? Okay. So arrays are a little bit weird in PHP. What you're really doing is you're mapping from things of one set to things of another set. So the unset function can have interesting consequences. Let's get XAMPP up and running, everybody. So, and of course XAMPP didn't load, because of course it didn't. I'm calling this file arrays.php. So let's say that we have an array defined in a somewhat standard manner. 1, 2, potato, true. Now we know that the unset function will remove an element from an associative array. It will remove the key value pair. But here's the thing. Arrays in a regular sense are also key value pairs. It's just that the keys are numbers. So I is less than count array I plus plus echo array at I echo, put a little sneaky break in there. There we go. So, just to show that this works, local host 1080 slash today's date 2025-09 17 arrays.php. There we go. So we can see that everything is printing. Okay, sure. Now how about a for each loop? There we go. So you can see that using a for loop and just pulling the value, or you can use a for loop to pull the values out of the array, using for each syntax, everything works the way that you would expect from Java. But what happens if you do a thing you're not really supposed to do? What if you assume that the array is an associative array? Interesting. So arrays are, in a sense, being defined as associative arrays, where the thing that is where the keys are being defined as the natural numbers. Okay. Sure. So what happens if you unset one of these? Let's say we unset the third element of the array. Well, our for each loop works, but you'll notice I'm missing an index. There's a little bit more cursed PHP for you. Looping over it in the normal fashion also results in a missing index error, right? Index 2 doesn't exist here, and the loop actually terminates after that. So removing element 2, you would think that that would be like a, take it out, the whole array contracts accordingly, and the indexes are corrected. No, not in PHP, unfortunately. So, How do you correct this? Honestly, this is kind of an edge case and it doesn't come up that much, but you know, it's still interesting to kind of reveal the structure of what's going on. Array values allows us to return, well, it returns all of the values of the array, but it re-indexes them numerically. If you're working with a numeric array, then this works. So, if we say that array is equal to array values, come on, of array, after that, you can see that the numeric array indexes have been, the whole array has been re-indexed so that you don't have any missing indexes anymore. But it's just kind of a curious thing. It's just a curious thing about PHP. Make sense? I mean, I don't know. It's another one of those situations where I shouldn't ask if this makes sense, but rather, can you follow what's going on? Because I'm not sure it makes sense for it to be designed this way. Any questions? All right. So, strings in PHP are character arrays. Because they are character arrays, you can access the elements of strings using indexing, which is convenient. So if you want a character out of an array, you don't have to use like the char@. I think it's char@, in Java that you have to use for that. But you can just directly index in PHP, so maybe that's a little bit more convenient. So, more on JSON encoding later, but let's give ourselves a little bit of an introduction to it. I'm hoping that all of you got a little bit of an introduction to JSON in client side. This is perhaps not universally true, but you know, for people who had client side with me at least, I tried to go over what JSON meant in some degree of detail. So, what happens, we've already seen this, but what happens when you try to echo an array directly? Anybody remember?
We'll just print array.
It will just print array, yeah. So, this is, you know, this is how it converts an array to a string by default. So, for example, if I take my array and I echo it, it gives me a notice about string, array to string conversion, and it just prints array. Further, if you think you're going to do anything clever, like, you know, concatenate with, you know, exclamation point. Like, that's how it string converts, right? So once it's a string, you can do any kind of string thing you want to it. So the way that we get it to not do that is to JSON encode it. right? Using JSON encoding, we are converting the data structure to an array using the normal mechanisms. So out it comes. Now, interesting. Let's see what happens if you fail to remap it. Yeah, if you fail to remap the indexes of the array, then suddenly we have an object popping out of that rather than an array in the regular sense. So it's checking to see if the indexes are continuous before it's printing it as a regular array. Make sense? All right. Any questions? How many people are asleep in the room? Let's see. Oh, that's okay. Because we're about to get to something a little more exciting. So far, we have talked about PHP for quite some time without ever having discussed how to take input from a user. Now we're going to talk about that. A very important concept in PHP programming is the superglobal array. Superglobals. Superglobals. So what is a superglobal for? The server takes all kinds of information that has come in with the incoming request packet, and it puts it into the superglobal array for you to find. That's where it puts stuff, right? So, there are several of them. For the time being, we will talk about the get superglobal. This is where query parameters that are sent with the incoming HTTP request packet are placed. It is an associative array. If you recall query parameters, they are key value pairs. Key value pairs are also what an associative array contains. The get superglobal contains precisely those key values. Key value pairs. So, let's review query parameters just for a moment. This is I can't help using this example, even though I occasionally get copy striked for it. It just seems mean to copy strike over the rickroll, you know? There we go. As long as ads. Get out of here. Anyway, I don't really need the, there we go. There we go. So, if we consider the URL, let's pull that into Notepad and dissect it, shall we? So here's our URL. Can anybody tell me what HTTPS is?
That's the protocol that
That-
you're using. The S for secure.
This is the protocol. Yes. HTTPS is the protocol which is being used. If you'll notice, sometimes you'll have things like FTP, sometimes you'll have things such as SSH, sometimes you'll even have things such as SQL. These are all packet protocols. What's this?
The domain.
That's the domain. That's right. Domain is, a lot of that gets into networking stuff, like DNS lookup and a lot of stuff that I don't even really know how it works. Probably very few people actually know how it works. But yeah, that's the domain for the website. How about this part?
The router, or the route?
Yes, this is the route. You might also call it the path. Path and route are synonyms, but in sort of classic web terms, the route used to correspond to directories in a file system. So this sort of mapped directly to a file path. This is how things still work on CS Unix. However, under modern modern development conditions, very often the route has encoded requests and parameters. We'll get into that towards the end of the course, but this is the route. Very good. What's the question mark for? What does the question mark do?
Parameter?
Parameters.
Or,
You're not wrong.
whether it's a get or a post.
Well, only get, not post. So the question mark separates the parameters from the rest of the URL. It is the character that starts the parameters. So, start get parameters. What does the ampersand do?
Separates key value pairs.
Very good. Well said. The ampersand separates key / value pairs. So you can see that we have 3 key value pairs here. They become a little more obvious when you put the spaces in. These are our get parameters. Does this make sense? So far, so good? Very good. So, these are the values that we want to read in our PHP script. Let's make a new one. Save this as input.php. So, one little trick that I like to perform, which I actually recommend everybody do, at least in the initial version of any PHP script you write, is to simply echo back everything that's been passed through get parameters, just to make sure that everything is working. Let me show you how to do that now. So, if we echo $_GET, we will have the same problem as before. Oh, I did that intentionally. There you go. So, echoing the get superglobal, we can see that it contains nothing. Nothing at all. But we haven't sent any parameters. put that URL here. Let's try this one. Oh, there we go. The data has now been loaded into the program. Make sense? Good. We now can use this information in whatever way we choose. Maybe we are adding this information to a database. Maybe we're using it to check credentials. Maybe it's the type of operation we are requesting. In the case of a YouTube video, the V key is the actual code for the ID number for the video that you're requesting to watch, right? So this stuff can be of very important stature. Now, here's an issue. This thing is just kind of straight up being dumped right into the web page, right? But let's imagine we're doing something a little bit fancier than this. Your name is get name. Recall that that has to be inside mustaches. Need a break in there. Very good. All well and good. But if we recall, any HTML tags that we send, that we echo using PHP, are interpreted as HTML tags. So, how about this? What if I think my name should be bold? Oh, look at that. I can make my name bold. Very good. But, you know, maybe I could do something else.
You can inject stuff.
You can inject stuff. Yep, that's right. What sort of thing could you possibly inject?
JavaScript file.
JavaScript file. Ooh. Let's see if that works. Script. Alert. You've been hacked, son. And script. Oops. We found an arbitrary JavaScript arbitrary code exploitation, arbitrary code execution exploit. There we go. So that's not good. This is a problem. This is a real problem. This is a real problem that real people have. All right? This is called cross-site scripting. I mean, well, this portion of it is not called cross-site scripting. This is a cross-site scripting vulnerability. This is arbitrary JavaScript injection. This is a JavaScript injection site, right? It becomes cross-site scripting when the script tag is loading JavaScript from some other server, right? You can imagine it would be, kind of a pain to encode all of your JavaScript in inside of the URL. Like, you've only got, I think, 4,000 characters to do it in anyways, right? But if you can have a script tag target a, steal your cookie.js, which is located on nastypeopleserver.rs, because of course it would be, then, you can just have, you can just run JavaScript on people's websites. But of course, the trick is, to make that work, you have to get somebody to click a link, right? You have to get somebody to click a link, because the link is where the link to that malicious JavaScript is hiding. So how do you get people to click links?
You disguise them as other things.
You can disguise them as other things, yes. Most particularly, well, basically you go after people's grandmothers. So this is why phishing emails exist, right? This is your plan of attack as a hacker, all right? Not that I'm telling anybody to be a hacker or advocating or condoning any kind of illegal activity. When we talk about how to hack things, we do it only for the purpose of defending against hacking. We are not hackers, we are good citizens, all right? The only reason we study the dark arts is so that we may have defense against them, all right? But if I was a hacker and I was going through websites, I would be testing them to see if they had XSS vulnerabilities. This is the sort of thing that websites frequently have. When I find one, I craft a sneaky email link. Now, even, you'd be surprised, what a grandmother will unfortunately click on. But, for anybody who actually reads the link, if they see script as a tag in the link, it's pretty much a dead giveaway. So what do they do? They just have they have it recoded as like HTML special characters and, a lot of like %sign 3D and stuff like that. It hides the script tag inside of a cluster of all kinds of characters that don't look like a script tag. But the URL itself ends up fairly long. Any URL that has like 3 lines, you probably shouldn't be clicking on it. Suspicious URLs. I think there's an XKCD cartoon about that. XKCD, suspicious URL. The mother of all suspicious files. There you go. Right? Don't click stuff that looks like that.
Yeah, that thing is like 3D axes in it.
Yeah. I mean, 0day hack.ers.
That movie turned 30 years old the other day.
Yeah, oh man. PHP. Don't click stuff like that. A lot of stuff ends up looking like this though, like if you actually, so the trick to not getting nailed by phishing emails is to always hover a link before you click on it. It'll pop up what the link actually is, and if it looks like that, don't click on it. So, yes, basically. So this is how they get in, right? Once in, there's all kinds of nasty stuff that a hacker can do. Using JavaScript, it's quite easy to write a keystroke logger. You guys know what a keystroke logger is? Who doesn't? Everybody does? Okay. So a keystroke logger is a program which logs your keystrokes. Every time you press a button on the keyboard, you can, all of you can write one having done JavaScript, right? All you have to do, you know that code that you wrote to capture some of you keyboard inputs for your SVG game, right? Just have every keystroke trigger an AJAX request that sends that key to, you know, nastyserver.rs. And by the way, .rs is the, it's like the .ca but for Russia. So that's the joke, because all hackers are from Russia. So, I mean, it's not true, but it's, you know, it's close enough to the truth to be a good joke. So, lost my train of thought. What was I talking about?
Keyloggers.
Keyloggers, yes, thank you. So all you have to do is write an event that captures a keyboard, each keystroke, send it to some other server, and everything you type is the property of the hacker. So what are the sorts of things you type on websites?
Passwords.
Username, password combinations, right? Yeah, nasty, 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 nasty. Another thing that you can do fairly easily is steal someone's session cookie, where this will be, you know, this will make more sense once we actually talk about sessions, but basically, stealing a session cookie allows you to duplicate someone's session on your own computer, so that, you know, they think they're logged into their bank. But really, there are two computers logged into their bank. Theirs and the hackers, right? Because of the way that, you know, because of the way that client-server architecture works, the server can't tell the difference between being accessed by one computer or 50 computers. If they all have the same state, then the server can't tell the difference. All right? So, we'll get there though. So this is a problem. This is a big problem. That's a problem. All right? I must impress to all of you that this is a problem. I must impress on all of you, I am contractually obligated to impress on all of you that if you use unfiltered get parameters, you are causing problems. You are causing problems for whatever company or organization you're building a website for. Big O problems. Big O giant hacky problems. Alright? So, I kind of already gave it away. How do you fix this?
Filter input function.
Yes, you filter your inputs. So, the general principle of filtering or sanitizing your inputs is easy to understand. The reason that that works is that opening and closing angle brace are what we would call control characters in HTML, right? They are characters which have special function. They open and close HTML tags. If we take out the control characters somehow, take them out or perform a substitution, they no longer execute as code, and this is blocked from happening. Does that make sense? So in principle, that's what the purpose is. Now, all of you are not experts in the current state of the art in hacking and finding XSS vulnerabilities, right? This is why we use functions written by very intelligent people to perform this filtering work for us. It is a mistake to attempt it yourself, right? It is perhaps even a deadly mistake to attempt it yourself. So, let me show you the correct way of doing it. In PHP, we have a function called filter input. Filter input, when supplied with the right arguments, will completely sanitize all of our incoming data in such a way that we will never have a problem with an XSS attack ever again. Okay? The first parameter that you must provide filter input is what sort of request this is. Right? What we are essentially doing, we are telling filter input which superglobal to look for the data in. In this case, we are expecting it to come through a GET request. So input underscore GET that's the value. When you see things like this in PHP, these are enumerations. So what this gets substituted for is just an integer value. It's like an option code that gets used by filter input. The enumeration tag allows you to use it a bit more semantically, right? You don't have to remember like, okay, 37 is input is for get responses, 38 is for post, You don't have to do all of that, you can just use input get, input post. It's a bit more semantic. Does that make sense? All right. Argument number 2 is the key that you are looking for. So in my case, that's name. Name. Expressed as a string. The third parameter is the type of filter you require for this piece of data. Different pieces of data, let me roll that back. When you send query parameters, they are always string encoded. This is why I can send something like age is equal to none of your business, right? It's like, obviously, the program should be expecting a number, probably an integer, usually an integer, but I'm getting away with not providing one because there's nothing about a URL that restricts that to being an integer. That comes once we hit our PHP code. So basically, for every data type, there is a filter name that you use for that data type. They're not too difficult to remember because most of them are the same. Strings are a bit different. So, for strings, filter underscore sanitize special chars. Please note this is not the same thing as sanitize string. One of the things that you have to be careful with if you are relying on not only the Accursive chatbot, but also internet tutorials of any variety, especially considering a great deal of them these days have been generated by the Accursive Infernal chatbot, and to the degree that the chatbot is wrong, all of the internet tutorials that you'll see are now wrong as well, and that just gets fed back into the chatbot as input. It's ingesting its own input, and everything's becoming garbage very quickly. Long story short, listen to me. I know what I'm talking about, in theory. At the very least, I'm going to be the one grading your paper. But filter sanitize special chars is a substitution filter. It substitutes the special control characters in the string for safe variants. There's another one, which you might be suggested. Filter sanitize string. This seems like an attractive choice because it makes more sense to read, but this is a removal filter rather than a substitution filter, and it is becoming deprecated. PHP is deprecating that in favor of special chars, so use special chars. Okay? Sound good? Question?
So, sanitize special characters. What does it actually do to it? Does it just delete them, or does it replace them with some other value?
I'm so happy you asked. Let's see what it actually does. So we'll try both, but here's the proper version first. Well, first of all, I have to tell you what. There's one more piece. The output of this function is the sanitized value. So unless you capture it in a variable and use that variable instead of doing this, you've done nothing. So let's say n is equal to this. Your name is n. There we go. Now, this is the effect of sanitized special chars. You'll see that our HTML tags have not been interpreted as HTML tags. They've been dumped into the text of the document. This is what appears to us looking at the page, but let's take a look at the network packet to see how things have been encoded. Preview shows you an HTML rendered view. Response shows you the actual, like this is the string that was actually sent from the server. You'll notice that many of these control characters have been substituted as follows. Right? So that's what it's doing. This control group renders as, closing square brace, but it's not an actual square brace, so it's not HTML.
Okay, that's just the Unicode of it, I think.
I think possibly, yeah. I think that's certainly the ASCII value. ASCII and Unicode overlap for as long as ASCII lasts. So, let me show you the difference now with sanitized string. I think if you enter think if you enter a sanitized string into VS Code, it'll even like highlight it in red that it's been deprecated. So you'll notice that quote characters, this has occurred, but you'll notice that like the tags themselves have just kind of been removed, right? It's just kind of snipped them out of the response. So yeah, it's probably possible to, you know, to trick this system by having it like, you know, leave behind characters that if those characters are adjacent, they would form a script tag anyways, stuff like that. So substitution is better than removal. Make sense? And you know, basically, we don't really have to think about it that hard or understand the reason. Our responsibility is to just use the most current and correct method and not use deprecated functions, especially when they're related to security. Don't ever use deprecated security functions, folks. Okay? So, does this make sense? Any questions? Yes?
Well, this seems pretty straightforward to do for sanitizing gets at least.
Yep.
Why is this such a big problem in industry with people forgetting to do this if it's such an easy thing to do?
It depends on what language you're using, right? In PHP, everything is like fairly exposed, right? So it's, I hate to say it, but a lot of people aren't very good at what they do. You know, like it's like there's a general problem with like people being, you know, unaware of things, and like, you know, a lot of people aren't good at their jobs. You know, I agree that like this doesn't seem difficult to do, and it's fair to ask why is there such a problem with this. But like one might also turn around and ask, why is there such a problem with people clicking email links and phishing emails?
That's true.
Right? Like,
I think we learned in class in semester 1 about how one of the ways to quote unquote hack a company is to get basically through the people, because the people are like the biggest weakness.
yes.
So you might drop like USB sticks in like the company's parking lot, and people will pick it up and walk inside and plug it into their computer to see what it is.
Yep.
It just seems really stupid.
Yeah, no, it's absolutely the case. This is called social engineering attack. I've got a couple of fun stories about social engineering attacks. So I remember this story from like the early days of like within the first couple of months of AI being like the ChatGPT model being released. Apparently someone took it and like jailbroke it somehow and got it to, like asked it to hack into someone's account. And this is how it did it. And it managed to do it, right? It called customer service, right? And pretended to be someone who was blind. And managed to convince, and using text-to-speech, managed to convince the actual human customer service agent that this was some poor blind person who'd been locked out of their account. So the customer service agent opened it up for them, and you know, bang-a-bang-a-boom, you lose all your money. Yes. There was another one. I was going to say, but you know, that's. Oh, on the subject of USB sticks, actually. So, my spouse is a member of the Royal Canadian Naval Reserve, and as such has access to military hardware, shall we say. So, in the military, they have like loaner laptops, basically, that are like, they use the military's intranet, right? There's a very interesting property of these things. You're not allowed to connect USB devices to them, not even mice and keyboards, all right? If you connect, and like these are like I think they're like Lenovo laptops or something, right? Some special kind of Lenovo laptop, or like, you know, like an IBM ThinkPad or something. If you at any point insert a USB device into one of these laptops, it sends out a panic signal to military headquarters, and military police come to your location wherever you are in the world, and they arrest you and they put you in military prison, and they also confiscate your laptop. And that is a thing that happens if you insert your USB card. It's also got like one of those things where you have to like swipe a card for access as well. But, yeah, it's kind of interesting from a hardware perspective. I also, you know, for various reasons, I haven't touched it or, you know, poked it or anything, because, you know, I don't want to be arrested by the military police for knowing things I shouldn't know. You know, yeah. So yeah, no, people are generally speaking idiots. Not you know, present company excluded, of course. Yeah, no, it's not really so much a question, why do things go wrong, but why does anything ever go right? You know? But yeah, security. Security, security, security. Good. So basically, in consequence of all of this, if you hand me in any assignment where I can hack it by doing an XSS attack, you will receive a marks penalty, all right? Because that is not okay in my classroom, okay? Writing code which is vulnerable to hackers is not on. Make sure you filter your inputs, please. Okay? So, let's do the same thing with age. Filter input, input underscore get. Get used to this line because you will be writing it a lot this semester, and there are several marks on every test just for getting this line right. Filter validate int, assuming that this is an integer that we're trying to read. So the validate filters are similar to the sanitize filter, but they're a bit different as well. They're not so much interested in trying to correct the string that they're given. They either pass it or they don't, right? The string is either an integer or it is not, and if it is not, we sort of reject it wholesale rather than trying to get the good parts out of it, right? So, there we go. There we go. You can see that at this point, it's not an integer, so it is just not printed, right? So, good. Now, there is something that I need to, something I'm tired of seeing in people's assignments, so I have to talk about it now, all right? On the subject of filtering. One thing that the chatbot likes to do, but is actually wrong, is to use a function called HTML special chars. Right? Now, in theory, HTML special chars is a function that is performing that substitution for the control characters in the string, right? In theory, it's doing what filter sanitize string is doing. However, to use this instead of that is to arrogantly assume that you know everything that filter input is doing and that it is only this. The contents of filter input are likely changing with each new release of PHP to keep up with the changing landscape of hackers versus defenders, right? Use the function filter input, all right? Using this function is kind of like you're taking too much on for yourself, like you're deciding, oh, I know what it means to filter, it means doing this. It's like, well, you know, what if in the future they find some new form of attack? And this is, you know, filter input is the one that you're supposed to use. So the fix for this new form of attack goes there, but this, it doesn't, because this is like a helper function for like one of these modes, right? It's like, just use the one I tell you, okay? When you, like, I believe what happens is if you say to the accursed infernal chatbot, oh, I noticed you used HTML special chars, could you give me a version using filter input? It will say something like, oh yeah, that's the one you're supposed to use, right? So, use the one you're supposed to use. And don't, for the love of all that's holy, accept unquestioningly security code from an AI algorithm. Alright? Security code should be based on best practices. Taking security code from the diabolical algorithm is as bad as finding some random internet article, copy-pasting that code into your server. Right? You don't know who wrote it. You don't know if there's been a backdoor built into it. It's like how everybody who uses like an online, you know, Google, generate me a password, is an idiot. Right? Because they just gave you your password. They know your password. It's not random. They gave it to you. They know it. They can use it against you. You know, like, it's a known password if it came from anything but a random number generator algorithm that you wrote yourself. Or perhaps one that you used that you thoroughly inspected the code for to make sure it's not sending it to anything or saving it anywhere. Alright? Like, I know I sound paranoid, alright? But, you know, at a certain point there's not that much difference between, like, good internet security and paranoia, you know? I had a student once who was working on a co-op and was getting a little frustrated with all of the security stuff. And he said to me at one point, well, at some point you have to trust something, and you have to trust someone. And I couldn't disagree more. Trust no one, rely on no one. Everybody is your enemy. Everybody is trying to hack you. Every single user is a hacker. If you think that way, you'll write better code. Alright? Okay. So don't use HTML special chars. If I see, I'm gonna write a thing into my script that greps it out, and if I find anybody who uses it, I'll be very, very substantially disappointed. I might throw in a special deduction, just Mark's deduction, just for using it. The AI is not a repository of truth. So
just to verify, you don't use filter sanitized string, use filter sanitized special
Oh.
filters.
Yes, special stars, yes, thank you. See, that's why I hate putting wrong things up on the board, you know? Like if somebody like jumps to that point in the video while I've got sanitized string up there, you know?
Yeah,
Out of context, it's like, you know,
yeah, or someone taking a photo like before class ends, yeah.
yeah. I try to make it a rule to never put anything incorrect on the board, but, yeah. You kinda have to, you know?
So you gotta show us what not to do.
Precisely. It's almost as like what not to do is, in the case of security, even more important than what to do. Like, you know, like PHP is an interesting language because you can absolutely know just enough to get yourself in a lot of trouble. You know, like this is kind of how server programming works. It's like, you know, someone who half knows how to program a server is extremely dangerous. That is a state of extreme peril. So, okay. Any questions about that? So, there's a set of validation filters, not just for ints. You've also got float. You've also got bool, or boolean. There you go. You've also got, well, actually, let's just look it up. Your documentation is php.net. Filter, sanitize, search that, see what we get. Here you go. So, sanitizing filters.
Ooh, we need to update that one.
Yeah. Sanitize. So this is kind of interesting though. Like there are sanitized filters for and validation filters for other string forms that are common, like email, right? Email addresses have to comply with a certain form. Same with URL addresses, and you can have sanitization and validation filters for both of those. Validate. There we go. Come on. Validation filters. There we go. Bool, boolean, int, float, regular expression, URL, domain, email, IP address, and MAC address. All of these are filters that you can use. Make sense? Okay. So let's return now to our int filter. So sanitization filters essentially have two outcomes. Either the string is there, in which case it will perform its substitutions. Otherwise, it gives an error state. It returns an error state, right? That error state is easily exposed. All you have to do is not provide even not provide the get parameter. So you can see it hasn't printed anything, but this doesn't this doesn't tell us very much. If the parameter is missing, the thing that filter input returns is a null literal. It returns null. Now, it returns null. Oop. You should probably say something. If it returns null, otherwise there we go. Name expected, otherwise it shows the name. Name expected. I forgot the rate. Always forget the rate. It says name expected rather than just simply, not give it, rather than simply not printing anything for n, we get a different outcome, right? Now, this is an issue because of weak equality in PHP. You may remember from last week I said, and the week before I think even, that the null literal equates to a whole host of things under weak equality. 0, false, I believe empty string and empty array as well. So, if, for example, we provide a name, but that name is empty, you can see we are encountering the null, like we're activating the null branch, but n is not null. It's an empty string. If we were using a filter which removed things, and it removed everything from the string, we would hit the same error. The way that we fix that is to tighten the equality. You can see, now that we are strictly testing for null, your name is blank, because name was provided and was blank. Does that make sense? Hopefully. It's a little bit more important when it comes to integers. You may have noticed that, the first assignment has quite a lot to do with numbers. So, pay attention. The same is true with numbers. So, if age is provided and is empty, we can see it's blank. This is not, this was the same thing it was doing when it was null. So let's let's reproduce the code above. If n is equal to null, else echo your age, echo age expected. If age is not provided at all, oh come on, say. Yes. If age is not provided at all, then, that'll do it, right there. There we go. Age is expected. Oop, get out of here. I don't want you, go away. Age is equal to, for example, empty string. we still get an empty string. An empty string is not an integer. Well, let me put that back to weak equality for a moment. So if I provide the empty string and we're just checking weakly for null, an empty string will activate this. This is perhaps not so bad because we do expect an integer and an empty string is not an integer. But what if age is an actual valid integer? In this case, 0. So 0, which is the actual character 0, is equating as being the same thing as null, same thing as false. This is an error. 0 is a valid age for a person. A person can be 0. This is not an error state. Yet, under weak equality, it's being picked up as an error state. Does this make sense? So, once again, the thing that you have to do is to tighten the equality. Further, there are two situations that we want to check. If the output is null, the value was not provided. If the value is false, then it didn't validate. It's there, but it's not an integer. So, for example, providing an empty string, integer expected. Providing none of your business also results in integer expected. So this is the point of a validation filter. The validation filter returns false to us when the value we have received from the user is not the data type we expect it to be. This is very, very, very important. Right? A lot of what hackers will attempt to do is to see if you've robustly validated your inputs. Right? To see if they can sneak a string in where an integer is expected. See how it behaves in a friggin' loosely typed language like this. Right? So, does this make sense? In JavaScript, the difference between strong and weak equality mostly didn't matter. You could use weak equality and get away with it most of the time. This is a concrete example in PHP where you cannot get away with it. Alright? You must use strong equality here, or else you are considering correct inputs to be errors. Does that make sense? Any questions? Okay. So let's talk about post then. So far, everything we've been doing is regarding get parameters, right? In order to adapt this code to work with post parameters instead of get parameters, it's quite easy. Literally, all you have to do is substitute get for post. This is now looking in the post superglobal. The post superglobal, very similar to the get superglobal, is where all of your incoming post parameters are stored when they are received from the user. This is where filter input post is looking for them. Now, here's a question. Here's a question that would make a good exam question. Do you have to filter post parameters?
Yes.
But I thought they were more secure.
You can still sneak in special characters in that, I suppose.
Precisely so. So just because you have this sort of magical thinking designation of post parameters are more secure than get parameters, that doesn't mean that they are somehow immune from hacking, right? When we say that they're more secure than get parameters, we mean that in a very specific way. How are post parameters more secure than get parameters?
They're hidden in the body, so that like, because the get just shows up in the header, which is public.
Yep.
And with the post, it's inside the packet. But if the client itself is the hacker, then that's that body is the payload that they're sending.
Precisely so. Post parameters are more secure while in the network because post parameters are stored in the payload and the payload is encrypted. That's the whole point of the TLS handshake, right? Post parameters are not they are more immune to things like man-in-the-middle attacks, right? That, as you say, if the hacker is the endpoint of the communication, if the hacker can decrypt packets, which all users can decrypt the packets, the hacker can very easily compose a message containing post parameters that contain XSS attacks. Now, it becomes somewhat more difficult to make a phishing email from the link, right? But any vulnerability is a bad vulnerability. You don't have to, specifically anticipate the way that you're going to get hacked to know that security is a good idea, right? So it's kind of like, it's like this, it's like, another good test question is AJAX requests, right? Everybody remembers AJAX requests from client side, right? Imagining that those are more secure than get parameters entered in a URL, because the URL is right there, but AJAX you need to know JavaScript to do, right? Imagining that means that AJAX is more secure than anything else is also wrong, right? Like, every hacker knows where the JavaScript console is. To send off an AJAX request, all you have to do is type fetch. Fetch and all your parameters, right? You can do that from the console. It doesn't have to be in a file. And it doesn't have to be a request that you wrote, right? People think AJAX requests are secure because, well, I wrote the request, right? So it's secure. It's like, well, yours might be, but that doesn't mean AJAX requests in general are, right? Yes?
So it's kind of like when it's moving through the network, it can't really be intercepted or modified, but it can still contain dangerous things from the origin.
Precisely so. And it can be modified. All it takes is a hacker to intercept the TLS handshake, which is more difficult to do, but certainly possible. Yes. So the rule is never trust the client. All right? I want everybody to say it with me. Never trust the client. Let's do it again. Never trust the client. One more time. Never trust the client. All right? Never. Nothing ever coming from the client should you trust. Never under any circumstances. Everything that the client has is fully exposed to the client. Nothing is encrypted, nothing is secure. PHP can be made secure, but client-side JavaScript never, cannot be secure. Not for any reason. This is actually the reason I hate Canvas quizzes. Well, it's like, you think that you're, taking vulnerable information that people want to have, like what the test questions are, and you're saying to them, oh, I'll just load that up into your client. Sure, yeah, great. All it would take is like running a JavaScript, running some JavaScript on it to harvest memory. Security doesn't exist on the client. The sooner you get used to the idea that security does not exist on the client, the happier you will be with your grades in this class. And also in your lives. Never trust the client. Okay? Shall we get to databases then? Yeah. All right. Thank you very much, everybody. Oh, and if anybody wants to see the shortcut, just hang around.